Welcome to Data Science 1, Probability, Conditional Probability. So if you remember, we have some rules that we've been playing around with probability, where E is an event and a sample space S. We know that the probability of the sample space is equal to 1. If we have the union of two events, then that's represented with like a U in the middle. And if we have an intersection of two events, that's talking about E and F having to occur at the same time. We'd use this upside down U, and remember that probability behaves like area. Okay, conditional probability is where we want to sort of update what we know about our probability once we see some event. So suppose we have two events and we observe an outcome that is in F. Okay, how does this change the probability of E? Well, if you look back at our Venn diagram, we have S, we have an event E, we have the event F, and we have the event E intersect F. Now, what did we just say? We said that we saw an outcome that is in F. So we know that that outcome is in this circle. That means we know that whatever happens had to have happened inside of F. So everything outside of it is no longer under consideration. So what we need to do is rescale our data, or not our data, but our question to only reflect outcomes that are inside of F. And we can do that using this formula. Okay, so this is the probability of E. This bar here means given F. So it's conditional on F. So that's the probability of the intersection here divided by the probability of the whole event E. So you can see how now, instead of it being like the probability of S down here, which would be everything, we're scaling it to just have the probability of F. All right, so let's look at a simple example. A vendor is selling oranges and mangoes as well as other fruit. Suppose we know that the probability of selling an orange to a customer is 0.3. We know the probability of selling both an orange and a mango to the customer is 0.12. What is the probability that a person who is buying an orange will also buy a mango? So we've seen them pick up the orange. We know they're going to buy that. What's the probability that they're going to grab a mango as well? Okay, so here's what we have. The probability of an orange is 0.3, and we know that if people, when they buy together, about 12% or 0.12 buy an orange and a mango. So our question is, given that we saw them pick up the orange, what's the probability they'll pick up a mango? So we take the probability of the intersection of mango intersect orange over the probability of orange. So we get 0.12 divided by 0.3, which is 0.4. Hence, there's a probability of 0.4, or about 40%, that a person buying an orange will also purchase a mango. So this idea is extremely important in probability and data science. It gives us a mechanism to update our probability when we have more information. So this is one of the pieces along the way that we're going to need. So just keep this in mind as we move forward, because these ideas will keep coming up. And we'll see you in the next video.